This video is about deriving the first two equations of motion and applying the equation to solve problems with constant acceleration. We need to be able to understand the notation involved when setting up problems using SUVAT equations. Okay, so first of all, we have a velocity time graph here. Then if we have 2 points, which is final velocity, and u, which is the initial velocity, and the time it takes to go from final velocity to initial velocity to final velocity is called t. So t is equal to t2 minus t1. Then gradient is equal to change v minus u over t, so changing y over changing x, which we know that the gradient is equal to acceleration, which is equal to acceleration, denoted a, which implies we get a is equal to v minus u over t, which can be rearranged to get v is equal to u plus at. So that's the first equation of motion, v is equal to u plus at. Okay, the area under the curve, or area under the line graph, area under graph is equal to displacement, remember? But if I wanted to work out the area under the graph, which is equal to this highlighted part, then it's the area of a trapezium, which means it's half of the two parallel sides, which is u plus v, times by the time, which is equal to displacement, which is normally denoted s. So that means we have s is equal to half of u plus v times t, and the way it's written is s is equal to u plus v over 2 times t. Another way, but I prefer this version. So half u plus v times t, and that is the second equation of motion. Okay, so both of these assume that during the period of time considered, the acceleration is constant. So this only works when acceleration is constant, i.e. the gradient on the velocity time graph is constant. NB, when using SUVAT equation, you must list the values of S, U, V, A, and T, and use the heading which identifies the time interval. It's best to get into that practice. Okay, so let's apply SUVAT, these two equations of motion, to some questions. So velocity, let's say, is measured in meters per second, and time is in second, and we know the gradient there is negative 0.5. So how would I use SUVAT equation to find the acceleration in the first 4 seconds? So you write label first 4 seconds. So label SUVAT and what we do know. So we don't know the displacement. We do know the initial speed is 3. We know the final speed is 7. We're trying to find the acceleration, and the time is 4 seconds. So if we look at that, we know we're using the formula v is equal to u plus at, which means 7. Now we substitute the values in. 7 is equal to 3 plus a times 4, which means 4 is equal to 4a, which means a is equal to 4 divided by 4, which is 1 meters per second squared. So that's the first 4 seconds. In the first 4 seconds, the acceleration is 1 meters per second squared. Part B now. How would you use SUVAT equation to find the velocity after 9 seconds? So now we'll write after 9 seconds, S equals U equals V equals A equals T equals. So trying to find the velocity after 9 seconds. So what we do know is 7 is the initial velocity. The gradient is negative 0.5, so that means the acceleration is negative 0.5. And we're trying to find, we know the time that it takes is 9 take away 4, which is 5 seconds. We know nothing about the displacement. So V is equal to U plus AT is the equation that we use. So V is equal to, we don't know what V is, so 7 plus negative 0.5 times 5, which is equal to 7 take away 2.5, which is equal to 4.5 meters per second. Okay, C. What is the total displacement? So displacement is the area. Displacement is A plus B. So when we're doing finding the displacement, so in first 4 seconds, we're using SUVAT, we're not using previous knowledge of area under curve. So displacement is what we're trying to find. We know the initial speed is 3, the final speed is 7. We don't know the acceleration, we know the time is 4. So S is equal to half of U plus V times T, which means S is equal to half of 3 plus 7 times 4, which is equal to 20 meters. So that is only first 4 seconds, which is just, in other words, A. Okay, we need to do the same thing for the 4 to 9 seconds. So between 4 to 9 seconds, which is B. We set up SUVAT again. So in that one, we know that displacement is, so we don't know we're trying to work out displacement. You know, U is initial speed is 7, final speed is 4.5. We just worked it out. Acceleration, we do know is negative 0.5, but we might not be using it. And time is 5 seconds. So S is equal to half of U plus V times T, which is half of 7 plus 4.5 times 5, which is equal to 28.75 meters. So if we're looking at displacement, A is positive displacement, B is negative displacement. So that means the final displacement is equal to 20 meters take away 28.75 meters, which is equal to negative 8.75 meters. For D, what is the total distance? Total distance will be, we don't care which way it's traveling, it's going to be 20 meters plus 28.75 meters, which is equal to 48.75 meters. A train traveling on a straight track is slowing down with constant deceleration 0.6 meters per second. The train passes one signal with speed 72 kilometers per hour and the second signal 25 seconds later. So first thing I would do is set up, obviously, find the velocity in kilometers per hour of the train as it passes the second signal. So S equals U equals V equals A equals T equals. So we have nothing about the displacement, so we don't know. The initial speed is 72 kilometers per hour. Now, if we times it by 1,000, that's 7,200 meters per hour. And then if we divide by 60 and divide by 60 again, then that is 20 meters per second, because we need it in meters per second, because the time is in seconds. So velocity, final velocity is what we're trying to work out. Acceleration is negative 0.6 meters per second squared. And time is 25 seconds. Okay, so we know we're going to use V equals U plus AT. So V is equal to U plus AT. So V is question mark, we're trying to find. U is 20 plus acceleration in negative 0.6 times 25, which we get 5 meters per second. Now that is in meters per second. So if we times by 60 and times by 60 again, we get 18,000 meters per hour, which means when we divide by 1,000, we get 18 kilometers per hour. So we needed the answer in 18 kilometers per hour. B, the distance between the two signals. So we got S, U, V, A, and T. So distance means we're trying to work out this. We have initial speed because we want the distance in meters, because the time is in seconds. We use the meters per second values. So 20 meters to final velocity is 5. Acceleration we don't care about. Time is 25. So S is equal to half of U plus V times T, which is half of 20 plus 5 times 25, which is equal to 312.5 meters. Okay, next question. A particle is moving in a straight line with constant acceleration. The points A, B, C line is this straight line. A, B, and C. The particle moves from A to B through B to C. The velocity of the particle at A is 2 meters per second. So 2 meters per second. The velocity at B is 7 meters per second. The particle takes 20 seconds to go from A to B. 20 seconds. Find the acceleration of the particle. A is equal to, so if I do SUVAT, so we don't know, the initial speed is 2, final speed is 7, sorry. Acceleration is what we're trying to find. And the time is 20 seconds. So V is equal to U plus AT. So 7 is equal to 2 plus A times 20. So 5 is equal to 20A. A is equal to 5 over 20, which is equal to 0.25 meters per second squared. The velocity of the particle C is 11 meters per second. Okay, part B. Find the time taken for the particle to move from B to C. So I should have said A to B is my subheading. This is B to C is my subheading. So SUVAT again. Again, I don't know the displacement. Initial speed is 7. Final speed is 11. Acceleration is constant, but which is 0.25 from the previous. Time is question mark. We're trying to find time. So obviously we have UVAT, so we have to use V is equal to U plus AT. So 11 is equal to U, which is 7 plus 0.25 times T. So which means 4 is equal to 0.25 T. So T is equal to 4 over 0.25, which is equal to 16 seconds. C, the distance between A to C, so between A to C, S, U, V, A, and T. We're trying to find the distance. We know the initial speed is 2, the final speed is 11, the acceleration is 0.25. Because we worked out B to C takes 16 seconds, so that's overall 36 seconds. Then if we want to find displacement, it's half of, or distance in this case, U plus V times T, which is half of 2 plus 11 times 36, which is equal to 234 meters. A particle moves in a straight line from A to B with constant acceleration 1.5 meters per second. So let's A to B, there is a C as well, A to B to C. So A to B is constant acceleration. I denote acceleration with a double arrow, so it's 1.5. Moves along a straight line from B to C with a different acceleration. So different acceleration, we don't know what that is. The velocity of the particle A is 1 meters per second. And the velocity of the particle at C is 43 meters per second. And the particle takes 12 seconds to move from A to B, 12 seconds, and 10 seconds from B to C. Find the velocity of the particle at B. So that means we're doing the journey from A to B, setting up SUVAT for that journey. So displacement, we don't know. Initial speed is 1. Final speed is what we're trying to find out. Acceleration is 1.5 and time is 12 seconds. So that means V is equal to, we're using the equation of motion, V equals U plus AT. So V is equal to 1 plus 1.5 times 12, which is equal to 19 meters per second. That's A. The acceleration of the particle as it moves from B to C. So B to C. So we're setting up SUVAT again. We don't know what the displacement is. We know the initial value. Now we know that it's 19 meters per second. So 19 to 43. Acceleration is what we're trying to work out, and the time is 10 seconds. So V is equal to U plus AT. 43 is equal to 19 plus acceleration times 10. If we rearrange it, 24 must be equal to 10A. So A is equal to 24 over 10, which is equal to 2.4 meters per second squared. So I can rewrite that as 2.4. C. The distance from A to C. Now the distance from A to C consists of two journeys. First of all from A to B, and then from B to C. So I have to do that part separately because I have to set up SUVAT separately for each part. So first thing, from A to B, I'm trying to work out the displacement. The initial speed is 1, the final speed is 19, acceleration is 1.5, and the time it takes to travel between A to B is 12 seconds. So because I'm trying to find displacement, I'm using half of S is equal to half of U plus V times T, which is half of 1 plus 19 times 12, which is equal to 120 meters. So from A to B, the traveling is 120 meters. Now I need to do the same thing from B to C. So SUVAT from B to C, we're trying to find the distance. Initial speed is 19, final speed is 43, acceleration is 2.4, and the time is 10. So S is equal to, again, I'm using the second equation because I want to find displacement. So it's going to be half of 19 plus 43 times 10, which is equal to 310 meters. So total distance is equal to 120 from A to B plus 310 from B to C, which is equal to 430 meters. Okay, a cyclist travels with constant acceleration x meters per second squared in a straight line from rest to 5 meters per second in 20 seconds. She then decelerates from 5 meters per second to rest with constant deceleration half x meters per second squared. Find the value of x. Okay, so first part of journey. So SUVAT for the first part of the journey. We don't know what displacement is. We know the initial speed is rest, so it's 0. Final speed is 5. Acceleration is x. And the time it takes is 20 seconds. So we're using V equals U plus AT. So 5 is equal to 0 plus x times 20. So 20x is equal to 5. So x is equal to 5 over 20, which is equal to 0.25. Acceleration is measured in meters per second squared. So that's part A done. The total distance she traveled. So B is, again, there's two parts to the journey, so we have to work out each distance separately. So first distance is first part of journey. So we've got S is equal to U is equal to V is equal to A is equal to T is equal to. So we're trying to find the displacement. We know it goes from 0 to 5. The acceleration we just worked out is 0.25 and the time is 20. So S is equal to half of U plus V times T, which is half of 0 plus 5 times 20, which is equal to 50. So 50 meters in the first part of the journey. The second part of the journey, S, U, V, A, and T. So first thing is we're trying to find S. U is 5 because she starts from 5 and then goes to 0. And the deceleration is half of x, which is half of 0.25, which is equal to negative, because it's decelerating, negative 0.125. And we need to find time. We don't know time as well. So the first thing we need to do is find time. So to find time, we can use V is equal to U plus AT. So 0 is equal to 5 plus minus 0.125 times time. So the time will be equal to -5 divided by -0.125, which is equal to 40 seconds. So that means 40 seconds. This journey is taking 40 seconds. So I can write 40 here. So now I can use S equals half plus S is equal to half U plus V times T, which is half of 5 plus 0 times 40, which is equal to 100 meters. So that means the total distance is equal to the 50 from the first part of the journey plus the 100, which is equal to 150 meters. Okay, a particle is moving with constant acceleration in a straight line. It passes through 3 points A, B, C. So A, B, and C, with velocity at 20 meters per second, 30 meters per second, and 45 meters per second. The time taken from A to B is T1, and the time it takes from B to C is T2. Show that T1 over T2 is equal to 2 over 3. So A is acceleration is the same for both. So that means acceleration is equal to V minus U over T1, which is equal to 30 minus 20 over T1, which is equal to 10 over T1 from A to B. Okay, for the second part, from B to C, acceleration is equal to V minus U over T2, which is equal to 45 minus 30 over T2, which is equal to 15 over T2. Now, because acceleration is the same, we know 10 over T1 must be equal to 15 over T2, which implies that T2 over T1 must be equal to 15 over 10 T1. Oh, we wanted the other run, so I've rearranged it the wrong way around. So that means we want T1. So take the T1 over. Oops. So take this one over there and this one over there. So I end up getting T1 over T2 is equal to 10 over 15, which means T1 over T2 is equal to 2/3, which is what we wanted. Given also that the total time taken for the particle to move from A to C is 50 seconds, so the whole thing is 50. Find the distance between A and B. So we know T1 over T2 is equal to 2/3. But that means because we know it all adds up to 50, T1 must be equal to 50. T2 must be equal to 50 over T1. So I can replace T2 with 50 over T1 is equal to 2 over 3, which implies that T1 is equal to, if I rearrange it, and not T1 is equal to 3 times T1 is equal to 3 times T1 is equal to 2 times 50 minus T1, which means 3T1 is equal to 100 minus 2T1, which means 5T1 is equal to 100, so T1 is equal to 20. If T1 is equal to 20, then it implies T2 must be equal to 50 to equal 20, which is 30. So that is 20, that is 30. So now I need to work out the distance from A to B. So from A to B, SUVAT. So this distance is what we're trying to find out. Initial speed is 20, final speed is 30, acceleration is, we don't know what that is yet, and the time taken is 20. So S is equal to half of U plus V times T, which is half of 20 plus 30 times 20, which is 10 times 50, which is 500 meters. Okay, the last question I'll go through. A particle moves in a straight line from A to B with constant acceleration. From A to B with constant acceleration. The particle moves from A with velocity 3 meters per second. So 3 meters per second and 5 meters per second after t seconds. 1 second after the first particle leaves point A, a second particle starts to move in a straight line from A to B with constant acceleration. Its velocity at point A is 4 meters per second. So it's the same thing. A to B, we've got 4 meters per second for the second particle. It reaches B with a velocity of 8 meters per second at the same time as first particle, but it left 1 second later, which means the time in between is t minus 1. So this is the first particle, the journey for the first particle, and the journey for the second particle. Now, it says find the value of t. So because they've traveled the same distance, we know that the distance traveled is the same. So distance traveled is the same for both. So it means using S is equal to half of u plus v times t. Then I end up getting, for the first journey, I get half of 3 plus 5 times t must be equal to the second journey is half of 4 plus 8 times t minus 1. Which means I get 4t on this side, and I've got 6 times t minus 1, which is 4t. 4t is equal to 6t minus 6, which means 2t must be equal to 6, so t must be equal to 3 seconds. Part B, the distance between A and B. The distance between A and B, you can use either part, so either 40 or 60 minus 2 distance, or 60 minus 6. Distance between A and B is equal to 40, which is equal to 4 times 3, which is equal to 12 meters, which must be the same thing as 6t minus 6. Let's just check. 6 times 3 take away 6 is still 12 meters, so it does work. Okay, just checking that it does.